This is Jack Jackson. In the last video, we talked about the rise of analysis, particularly real analysis, in the 19th century. But it wasn't only just real analysis that was growing at that time. Also, this idea of analysis was applied to complex and vector analysis as well. So in addition to establishing a rigorous foundation for calculus, calculus was expanded into new directions applying calculus techniques to functions of complex numbers and vectors. And this at least started well in the 19th century. Many of the same mathematicians working in real analysis were also working in complex and vector analysis, most particularly Cauchy. Complex numbers are numbers of the form a plus bi, where a and b are real numbers and I is the principal square root of -1. Now, they'd been around for some time, but not used much except as an aid in finding real solutions to polynomial equations. They were not really given as equal standing with real numbers, but they were recognized as an important tool to be able to use. In 1797, Wessel gave a geometric way of representing complex numbers as a point AB in a plane or as a directed line segment from the origin to that point. It was not widely read or used until Gauss published proofs using this visual representation. And complex analysis is using calculus techniques on functions whose domain or range are subsets of the complex numbers. So Cauchy was the first to make major advances in complex analysis, making him the founder of complex analysis. One concept that this led to was the idea of a line integral, which can also be used in vector calculus. Riemann was another major figure in the development of complex analysis. Calculus was expanded to apply to vector functions also in the 19th century. There are three major theorems for vector calculus, each of which are a type of extension of the fundamental theorem of calculus. Riemann stated Green's theorem in 1851. Gauss worked on the divergence theorem in some cases, with the general version of the divergence theorem being published in 1826 by Mikhail Ostrogradsky, who lived from 1801 to 1861 in Russia. By the way, it was his textbook that was papered on the walls of Sonia Kovalevsky's wall when she was a child. George Stokes, from 1819 to 1903 in Ireland, proved Stokes' theorem in 1854. And so if you look at my videos from Calculus 3, I can give an explanation of what these three theorems are and some other vector calculus concepts and applications. But know that that portion of calculus, which is typically taught in a course probably called vector calculus or maybe calculus 3, which is what we call it at our university, that material comes from the 18th century. So the calculus that you study in the calculus 1, 2, 3 classes and even in differential equations, that material was started back in the 1600s by Leibniz and Newton, but it wasn't just sort of fully formed then. It developed and people were adding to it over the next century, where they added things like new differentiation rules, new integral rules, new antiderivatives, applications to new kinds of functions, and so forth. Then we worked on getting the foundations of it shored up more in the 19th century and expansions into other areas, including things uh, like Green's theorem, divergence theorem, Stokes' theorem. So vector calculus work with sequence and series. Some of this stuff was added on in the 19th century. So by the time we get to the end of the 19th century, we've got calculus pretty close to the way we study it now uh, in this century. But as we're pointing out in this video, complex and vector analysis were also added. Complex analysis is now considered one of the main areas of mathematics for pure mathematics.